titration method in which iodine is liberated from potassium iodide by some oxidizing agent, and this liberated iodine is titrated against standard sodium thiosulfate solution, is called iodometric titration. What is the major difference? There are two major differences which you should remember. The first one is we don't have iodine here. Iodine is released within the reaction, and reaction is with that substance whose concentration is to be calculated. So understand it. Suppose we have a substance A, we have to calculate the concentration of A. What we do? We get it reacted with Ki and we get iodine liberated here. This iodine is again titrated with thiosulfate ion using the same equation which we use in iodometric titration. So this reaction will be same as in iodometric titration, the second one. Then how do we calculate the concentration of the original substance we used? That is something I am going to explain here. For example, Cu2 plus ions, maybe copper sulfate, is estimated by oxidizing the iodide ions, that is Ki, which we used here, okay, to liberate iodine. This liberated iodine is titrated with sodium thiosulfate. In this case, this is sodium thiosulfate. We don't use any other reducing agent. We use sodium thiosulfate only. This can be different. This can be substance whose concentration is to be calculated. So this is unknown. In this case, another difference from iodometric titration is that sodium thiosulfate concentration is known. So we use a known concentration of sodium thiosulfate which reacts with iodine liberated from the reaction of copper ion with Ki. So from here we can get the concentration of Cu2 plus. So understand what is the sequence. The sequence is you know the concentration of Na2S2O3. So you know how much was used after the titration is complete. From this you will calculate how much I2 got consumed because this reaction takes place between iodine and sodium thiosulfate. From this we will calculate how much Cu2 plus was there, because Cu2 plus when reacts with Ki gives you Cui and I2. So this is the reaction which takes place when copper reacts with iodide ion. This iodide ion is from Ki, so you can write 4Ki instead of 4I minus. When this cuprous ion reacts with iodide ion, we get Cu2I2 and this iodine is released. This iodine is actually titrated with known amount of sodium thiosulfate. From here we can calculate the amount of I2 which was liberated. So because this amount is known, from here we will get, okay, half the moles of I2 will be consumed. So we calculate this one. This is also known now. So now iodine is known. We know the relationship here also, means we can calculate how much copper sulfate was used. In these iodine titrations, endpoint can be detected by adding freshly prepared starch solution. It reacts with iodine in the presence of iodide to form intensely blue colored complex. I will explain it with the details through steps. This color disappears as soon as the iodine is consumed by the thiosulfate ion. So it is very much similar to the iodometric titration. The difference is that here we use known amount of sodium thiosulfate ion. In case of iodometric, it was unknown. It was that substance whose strength was to be calculated. Thus the endpoint can easily be tracked and the rest is the stoichiometric calculation only. Steps involved in iodometric titration: take the analyte solution, for example copper 2 plus. This is the substance whose concentration is to be calculated. So we take this into the iodine flask, add excess of Ki solution to get iodine. So from here we add excess of Ki so that no unreacted copper sulfate is there. To ensure that entire copper sulfate is used, we add excess of Ki. Now we have maximum iodine which could be produced by analyte. Now we add the indicator, that is starch, simple starch, or sodium starch glycolate, which is a better indicator, and we get blue solution. Now we take a standard solution of sodium thiosulfate in a burette. A standard solution means we know the concentration of this particular substance, sodium thiosulfate. Now we titrate the iodine solution in flask with sodium thiosulfate by adding sodium thiosulfate drop by drop. So initially this is blue because we have iodine and starch both here. But when we add sodium thiosulfate, it will consume iodine. Once entire iodine is consumed here, the blue color will disappear. So at the end point, the color of iodine solution will disappear. Now, how do you calculate the strength? These are the two reactions happening. This is analyte whose concentration we have to calculate. We get it reacted with excess of Ki to get the iodine liberated. This iodine we get reacted with known amount of sodium thiosulfate, and from here we know how much iodine was liberated, because we know that 2 moles of sodium thiosulfate react with 1 mole of iodine. With this relationship, whatever sodium thiosulfate is used, on that basis we calculate half the moles of that will be iodine. So if we know the iodine liberated, from here we can get how much copper sulfate was there, because the ratio again, if 1 mole of iodine was liberated, it means 2 moles of copper sulfate were present there. So we can get the concentration of copper sulfate from this relationship. So for example, if you got that 100 milliliter of Na2S2O3 by observing the decrease in the level of burette was used, and you had 10 m means molarity was 10, Na2S2O3 solution, then in 100 ml 1 mole of Na2S2O3 was present. If the molarity is 10 m, it means 10 moles are present in 1 liter of solution. But we have only 100 ml. 100 ml means 0.1 liter. So in 0.1 liter, it will be just 1 mole. Unitary method I am applying here. So we get the concentration of sodium thiosulfate used. From here, we will calculate how much iodine was liberated, because for every 2 moles, 1 mole iodine is liberated. So here we have 1 mole of sodium thiosulfate used, it means half of that will be iodine. So 0.5 moles of iodine was liberated, it means. And then again we have relationship that for 1 mole of iodine, 2 moles of copper sulfate will be used. So here for 0.5 double, that is 1 mole of copper sulfate was there. So it means 0.5 mole I2 were liberated by Cu2 plus, and hence we can say that 1 mole of copper sulfate was present. You can skip the step from here to here, because you can see I2 is same in both. You can directly say whatever moles of sodium thiosulfate will be used, same number of moles of copper sulfate were present, 2, 2, same ratio. Okay. So if we got that 1 mole of sodium thiosulfate was used, it means 1 mole of copper sulfate was present in the analyte. And from that we can calculate the strength, molarity, because the molarity will be number of moles divided by volume. So whatever volume was there here of copper sulfate, and if you know the number of moles, divide that number of moles by the volume of copper sulfate solution, you will get the strength, molarity. So according to equation, 0.5 mole of I2 would be liberated by 1 mole of copper sulfate. Once you know the moles, and suppose the volume of the copper sulfate was 50 ml, then you will get the molarity as number of moles divided by volume of solution in liters. It will be 1 mole divided by 50 milliliters, that is 15 to 10 power minus 3 liters. When you solve, it will be 20 m. That is just an example to elaborate how do you calculate the strength of the analyte. Now all the steps through flow diagram. It is important that you can recall all the steps. First one, take the analyte solution, that is copper sulfate. In the iodine flask, you have to add excess of Ki solution to get iodine here. Why do you add excess of Ki? To ensure that entire copper sulfate is used. Otherwise, some copper sulfate might remain unreacted. You will get iodine from here. Then you add indicator starch or sodium starch glycolate in the flask. So that iodine along with starch will give us blue solution. Take a standard solution of Na2H2O3 in burette. Standard solution means of known strength. We already know the molarity of this particular solution. Titrate the iodine solution in the flask with sodium thiosulfate in the burette by adding sodium thiosulfate drop by drop. At the end point, color of iodine solution will disappear. It means we know how much Na2H2O3 was used. From that we will calculate how much iodine was used. From that we will calculate how much copper sulfate was present. So from the amount of sodium thiosulfate used, calculate the amount of iodine liberated and then molarity, that is the strength of copper sulfate.